Okay, we're going to look at working with the factored form of a quadratic. So we've been given a quadratic, and it's obviously in factor form from the title. This is the factor form we use. It's known as A being the term that's kind of common factored outside of everything. In this case, if there's no number there, do you know what number A would be considered?
1.
Yeah, it'd just be considered 1. The R and the S in this style of factor form are our X-intercepts. And what we mean by X-intercepts is that if we have a graph, I'll fix that in a sec, our y-axis, as of right now, let's say we don't know where the x-intercepts are. But an x-intercept would be where it crosses our x-axis, essentially where the y value. Okay, so on the x-axis, this is where technically y is equal to 0. So here are your two x values. This could be an r, and this could be s. Okay, and if you'll notice, there's a negative in front of both of those. So what that means, if say r happened to be the number 5, well, when I go to plug it in, it would look like -5 in here, okay? Now, in this version, it's important to just quickly realize that the coefficients in front of the x's are both the value of 1, okay? So what that means is by looking at this one, it's really easy to tell what our r is. Our r is positive 1. And if we were to pull it out because it has to be negative, it's kind of the opposite of whatever operation that is. So really, this x-intercept is going to be -1. So let's call that the -1. Okay. This one here is not so easy to see. It's not 5 because the coefficient is not our 1. There's a couple ways we can do this. I'm going to show you an uncommon way, but a really quick way to do it. I'm going to factor out the coefficient in front of the x, just of that bracket. Okay. So say we move down here, nothing else has changed. Our a value is still 1. We have our x plus 1. And what I'm going to do is I'm just going to divide both of these by 2. Okay? And what that leaves us with is the 2 comes to the front of the bracket, and you're left with x plus 5 over 2. And do you know what that number happens to be? That'd be 2.5. Okay? So we'll say plus 2.5. I won't do that, right? I'll just write it. So if it's 2.5, again, if we're pulling it out, it's the opposite idea now. It's -2.5. So here's your -2.5. So maybe this is a little closer to where the r is, and this is a little closer to where the s is. Okay, this is one way of doing it. Our a value was 1, and I just still want to draw your attention to this. Because technically we drew that 2 out, we should move the 2 over, and the true a value in this one is actually 2 times 1. So 2 times 1 happens to be the value of 2. Nothing else changes. There's a rule in multiplication called the associative property. The name's not so important, but what it means is that we can multiply things in any order we like, and you still get the same answer. So 1 times 2, I know that technically should have been 1 times this entire bracket and then times 2 in terms of a bed mass order, but it doesn't really matter. So I just pull the 2 over and multiply it so to simplify that term. Okay, so now we're in what you can call a true factored form, where the coefficients are both the value of 1 in front of x, and then it's really easy to see what our x-intercepts are. Our x-intercepts from this should be -1 and -2.5. Those are the two x-intercepts. Another way we could have done this, okay, is because we know y is 0 and f at x kind of represents y, we can replace f at x with 0. So let's take the original first equation again, okay? Let's consider this a different version. 0, and I'm going to use the original brackets. We still have that value of 1, x plus 1, 2x plus 5. Okay. Well, I want to start isolating for x. Okay. Well, I need to get rid of this 1 first. If I divide everything by 1, you kind of cancel out or consider a 1. Really, the 1 doesn't do anything. We can kind of just drop it. But say this number was 2 and we had to do it with the number 2. What's great about this is because it's set equal to 0, 0 divided by 2 is still 0. So essentially, you can really just drop our a values in this case. Okay, so now that we've done that, we have 0 is equal to x plus 1, 2x plus 5. Great. Each of these brackets represents a term. Let's say it's a and b. A times b is equal to 0. In order for us to get 0, one of these values must be 0. It's the only number that we can multiply and get 0 in math. So we're going to test for both of them being 0. And what I'm going to do is split the equation here, and I'm going to have two answers, which makes a lot of sense because up here we have two x-intercepts. So we have 0 is equal to x plus 1, and 0 is equal to 2x plus 5. So we're going to isolate for x in both of these. In this version, I move 1 over. It becomes 0 minus 1, which is just negative 1. In this version, I move 5 over. It becomes negative 5 equals 2x. And then I take that 5 and I have to divide both sides by 2. It becomes negative 2.5. And lo and behold, negative 2.5 and negative 1 were the exact values we found here, negative 2.5 and negative 1. So both of these work for finding x-intercepts. As long as we're in this style where the coefficients are the value of 1, you can just take the reverse or the opposite operation of the value of the term, and it'll tell you exactly what it is. If you're not familiar with that, you can kind of set it up this way and set it equal to 0. So that's one piece of information that's really good for us. And we can test that. I've quickly shown on a graphing calculator here. Here are things. X value at negative 2.5 and another one at negative 1. Let's zoom in a little so you can see the difference. There, exactly what we had before. And even if I put the value of 1 here, it doesn't change anything, right? The next thing I want to do is find our vertex from here. We can do it. Essentially what we're going to do is find what's called the axis of symmetry. And the axis of symmetry is a line that kind of runs down the middle. I know I didn't draw that perfectly. The good thing about it, if it runs down the middle, it's exactly what the x value of the vertex must be. Okay, so if we're trying our x and our y, the axis of symmetry is our x value, okay, of our vertex. So the formula for axis of symmetry is that we take our r plus our s and divide them by 2. We take our two x-intercepts. In this case, that's negative 1 plus negative 2.5 divided by 2. When we add those together, we get negative 3.5 divided by 2. And I like fractions. Personally, what I would do here is I would turn this, I'd multiply both by 2, and I'd get negative 7 over 4. But that might not be really clear to you, so let's work with decimals. Negative 3.5. Where's my negative term? Can I do it that way? Nope, that's not what I wanted. Sorry. 5 divided by 2 will still work that way. Oh, well, good. Negative 1.75. Great. So our x value is negative 1.75. Either of these are acceptable answers, okay? So the x value of our vertex or our axis of symmetry is that value. X is a negative 1.75. Now the y value of the vertex is unknown up to this point. And what we can do is we can plug our y value directly in. Okay, we can plug it directly into our factored form. And above, I kind of showed you two different factored forms. There was this one, and there's the other one where we factored out the 2. They're both the exact same thing. Do you care which one we plug it into? No. I'm going to plug it into this one because I want to show you a logical trick that if we use this one, we can always tell we have the right x-intercept by what something happens in this. In this version here where we have a coefficient in front of the x, we can't technically use that trick. So I'm going to use that version. It's the same thing. We had f at, technically the term is negative 1.75, so we'll go plug it back in. And we had x plus 1, sorry, and we had a value of 2, and we had x plus, I believe it was 2.5. Put my computer going nuts. Yeah, plus 2.5, and the 2 is out there. So I took that version out. So we have to replace the x in both of these with the negative 1.75. So when we do it in this version, we're going to find a neat little trick. You get negative 1.75 plus 1, negative 1.75 plus 2.5. Okay. We get 2 times. Here we'll get negative 0.75. And in this one here, use a calculator. I can tell you what it is, but we'll do it just to prove it. It's negative 1.75 plus 2.5, and we get positive 0.75. So whenever you plug it into the version that has just, you know, a coefficient of 1 in front of both x's, when we go and plug our x value in, we should get like the opposites of each other, the positive and the negative value. And what that means is that number must be directly between in order to have the same distance, right? To be the same distance from one to the other means the number we're using must be directly between. If we plugged into the other one, you wouldn't have found that you would have had two kind of different values. So this is just like a logic check for us. We definitely had the right number. That's great. And then from here, we just kind of multiply across. We got 0.75 times point. Can I do negative? I feel like that's not right. I'm going to do all the positive versions because I'm not sure if that's going to make it a subtraction question or not. And I'm just going to keep in mind that we have a positive times a negative, which makes a negative, and then a negative times a positive, which keeps it negative. So I know my answer will be negative, and all I'm really looking for are my values. So times 0.75 times 2, 1.125. So we get negative, it's really important that I remember that, negative 1.125. And I could have used fractions if I wanted. We stuck with decimals, so negative 125. Okay. And if we go and take a look at our graph here, at our vertex form, negative 1.125 and negative 1.75. So I found tons of information. If I needed to sketch this, I could have made a really rough sketch, which I was kind of actually doing above. We've already started it. Here's our rough sketch. We'll put some more values in. We'll go down here. Our rough sketch, because we obviously don't have graphing calculators on tests usually to build these things. One of the x-intercepts was -1. The other was -2.5. Okay, and the vertex was at -1.75, so directly between those two. And the y value was -1.25. So here's a rough sketch of what we're doing. We could have also found the y-intercept if we really wanted. You can do that by kind of just multiplying our final two terms. But essentially, this is a great rough sketch. This is all we need. And if you recall, I'm just going to show you one extra step we usually don't do. I can put this in vertex form really simply. The a value is the same as above, so it's still our 2. Our x value of our vertex is our h, right? So if our x value of our vertex is -1.75, I go minus -1.75 squared. And the y value of our vertex is our k, and it's -1.125. And I'll just kind of simplify our brackets and stuff in here. So the vertex form would be 2x plus 1.75 squared minus 1.125. And if I quickly show that, essentially I just took the values. Were you okay with that?
Yeah.
Plugging them in h and x. If I kind of just type it in here, 2x plus 1.15 squared minus 1.125, and we take a look at turn the blue off, it's the exact same function. So we can quickly go to that other version of it. I know that was a long one, but lots of ideas all together. It can tell you so much information in the factored form.